So you've learned a whole bunch about acids, a whole bunch about bases, how to compare them to each other, and how to name acids. On Thursday's lab, pH was a really big thing. We looked at indicators and color changes to indicate high pH or low pH, which indicates acid or base. But the question that no one has asked is, well, how does that number even exist? That's fine that we say that a strong acid might have a pH of 2. But where's the 2 come from? And that's what today is. I want to show you how by looking at molarity and a new equation that we can run some quantitative analysis to actually assign the pH. But before I show you that new equation, first off, look to the back of your cheat sheet, and you'll see that I'm in the top section where it says pH calculations. If you look at the projector, for those of y'all at home, I don't know if you can see this real good, but here's what's being projected if you want to pause and study it. If you take a look at the screen here, there's a secondary system in addition to pH. We know that pH runs from 0 to 14. If you're below 7, the pH will indicate an acid. If you're above 7, it'll indicate a base. But there's a secondary system that goes the opposite direction. It's called pOH. And you'll notice that it simply works in the opposite way. pH looks at how acidic something is, where pOH looks at how basic it is. All right, it's the power of hydrogen versus the power of hydroxide. But what I want to show you is that in any given beaker, in any given solution, you draw what I draw. Every solution has a pH and a pOH. It's got both numbers simultaneously. And all you need to understand for these two values is that when you add them together, they always equal 14. In other words, if I said that whatever this solution is had a pH of 5, first off, is it an acid or a base? It's an acid because any pH below 7 is an acid. So we know the whole thing is acidic. What's the pOH? Well, this plus this must equal that. So what's the pOH? 9. And if you look at the scale there, you'll see that the 5 and the 9 are lined up. But you'll also see that a pOH of 9 is acidic, the same way that a pH of 5 is acidic. All right? So where I'm looking at is right here. Right, yeah, the pH of 5, the pH of 9, both of them acidic in that red area. So we could show this again. Build a new beaker. Build one with me so you've got these examples in your notes. All right. Again, all solutions have both. Both numbers exist simultaneously. So let's do different this time. Maybe I'll give you the pOH. Let's say it's got a pOH of 2.5. The pOH of this solution is 2.5. Now be careful when I ask you this question. Is that solution acidic or basic? It's basic. Now the reason that your brain got confused maybe is that right now your brain's been taught, well, if the number's below 7, it's an acid. Yeah, if the pH is below 7. What's the pH here? Remember, the whole thing equals 14. What is it? 11.5. Do you see why it's basic? The pH is above 7, making it a base. So be careful. Don't let your mind get confused. The scale that you've memorized is the pH scale. So keep that in mind. Just make sure that whenever I ask you, is it an acid or a base, make sure you've got the pH number in front of you, not the pOH. The pOH is important. I can ask you for it now because you know how to find it. But the pH is the scale that you're used to. The pOH scale is reversed. You try one. I want to know what the missing value is and whether the solution is an acid or a base. What's the missing value, and is the solution an acid or a base? So if you had that scale in front of you, you could just put your finger on the pOH of 6.7, in between the 6 and 7, and see where the other guy lies. But we know that the two values together will equal 14. All right? So mathematically, 14 minus 6.7 is 7.3. So this solution has a pH of 7.3, a pOH of 6.7. Is he acidic or basic? Yeah, look right there. The pH is above 7. pHs above 7 are bases. You could also say that pOH is below 7 are bases, and that would absolutely always be true. But most of y'all would like to only have one scale memorized and go off of that. Yes, sir?
So if it's pH is lower, then I'll be more acidic. If it's pH lower, then I'll be more acidic.
Right. Exactly right. Now, that's the easier part of today, is understanding that simple equation. If you look at your cheat sheet, you'll see that it's there. It says pH plus pOH equals 14. So you do have that value available. I'll give it to you on Monday's test. This will be our first problem for calculating pH. There's two different types of things that can happen in these problems. They're both very easy. You just have to realize that there's two different routes you can go down. Both of them use this new equation, which is negative log. That's a logarithm, but it's just a button on the calculator of what we say H plus, which will be given a number. All right, and that's how you're going to find pH. But here's the deal. There's also always going to be a compound given. If it gives you an acid, then you're just going to do this formula. And I'll show you the formula in a second, so don't be confused. If the problem gives you a base, you're still going to use this formula, but then you have to subtract minus 14. I'm sorry, reverse that. 14 minus that. You're not allowed to get a negative number. Do you take notes in pen? 14 minus the negative log of H plus. Now let me show you what I mean. Look at this problem. Yes, sir. Take a look at this problem here. Look at the compound in it. Find the compound, elements from the periodic table. Is this an acid or a base? It's an acid. How do you know it's an acid? Starts with H. So look, I'm going to put a little bubble there. I'm using this route. I'm using this thing here because the compound it gave me is an acid. This equation computes acidic pHs. It doesn't compute bases. The reason you have to do this 14 thing for bases is because it's going to give you an acidic number, and if you subtract that from 14, it'll give you the other side of it like we did a moment ago. Let me show you how you enter the number. In your calculator, you're going to type in negative log, and I'll show you where those buttons are. And then where this H plus is where the given value needs to go. In this case, it's 5.5 E negative 3. Y'all remember your E? We've done exponents in the calculator before. Let me show you how to get there if you don't remember. The negative button is the one next to the decimal. All right, so start off by hitting him. You'll get your negative symbol. The log button is right below the second key. Hit him, and he'll even open up parentheses for you. He's a nice button. The given value is 5.5, and here's where it says you're supposed to do times 10, but I don't like putting that in the calculator. Instead, you just want an E to represent times 10, and the E is the secondary function of the button above the 7. So hit second and the button above the 7. If you're on the other calculator, the light blue one, it's the primary function of the same button. You just don't have to push second. Everybody get the E to pop up? And now to the -3. You don't even have to close those parentheses if you don't want to. It's fine if you do. But it's going to spit out a number. What number did you get for the pH of this solution? Yeah, I get 2.26 if you round correctly. The pH of this solution is 2.26. Is this an acid or a base? It's an acid. It's got a pH below 7. Now I'm going to erase my red mark that I made. All right. I decided to use this, again, because this problem used an acid. Let's see what happens when the problem uses a base. Example 2. Does this problem use an acid or a base? What is it? It's a base. How do you know it's a base? Because it ends in an OH. All right, so you've got to remember stuff from last week to do that part. Acids start with H, bases end with OH. So look, I'm going to put my little dot here because I know I'm using the basic rule. I want to go 14 minus the exact same thing we just did a moment ago. Now, you've got some order of operations you have to worry about here, so watch how I do this. In my calculator, I'm going to put 14 minus. But then I'm going to open up my own parentheses before I put in the rest of the stuff. Negative log of the number they gave me. 9.4 E -5. Any questions about anything I did there? All right, so 14 minus the negative log of the number they gave me. And that's exactly how you'll type it in. 14 minus, don't use the negative symbol, those are two different things. All right, I'm going to open up my own parentheses so that order of operations is happy. Then negative log, then it'll open up that next bracket. 9.4 E -5. We'll see if you get what I get. Did you do something wrong or you have an answer?
Yeah.
I'll come look. What'd you get? Those yellow didn't get an error.
I got 9.97.
Perfect. 9.97 would be my pH. Keep in mind, the only reason we did this 14 thing was because we were analyzing a basic solution. All right? And we ended up with a pH of 9.97. Is this solution more acidic or more basic? More basic, as it should be, since it's a solution of NaOH. Let's do another. So remember, the biggest thing to do is ask yourself, am I analyzing an acidic solution or a basic solution? because that determines how you're going to use this negative log to find the pH. All right, is that an acid or a base? It's an acid. Starts with an H. My acid says just take the negative log of the number that they gave you, which in this case is 2.6 E negative 7. Again, that if you put a minus instead of a negative for either of these guys, it's going to give you an error. You've got to use the number, the button rather, next to the decimal. Negative log of 2.6 E negative 7. What's the pH? 6.59. That next number that you get rid of can bump that number up when you round. Hey, I could be even more twisted in my question, though. What other number could I ask you for here? I could ask you for the pOH. You can find the pOH now, because we know that that number plus this number equals 14 always. So what's the pOH? 7.41. All right, and that was just, to get that, he just did 14 minus 6.59. All right, you just got to make the expression true. But I can combine the skills. Let's do another. Is this solution acidic or basic? Basic. It ends in OH. So if it's a base, I need to go 14 minus the negative log of the number. In this case, it gives me a molarity of 7.9, E negative 2. All right, so remember, on your calculator, it's a minus and then a negative and a negative. (14) minus negative log 7.9 E, secondary key of the button above the 7, negative 2. What pH did you get? Yeah, 12.9 is really what it rounds to. 12.90. Another basic solution. What do y'all think about this skill?
Pause and answer both of these.
Our first problem looks at this compound in a solution. What's the name of that compound? Somebody say them. Strontium. Not hydronium. OH, not hydronium. What's OH? Hydroxide. I promise that'll be a test question, so be on fire, Monday morning students. Strontium hydroxide. We know that hydroxide-containing compounds are basic. Therefore, I'm going to do this expression, which is 14 minus the negative log of the value that it gave me, which is 4.1 E negative 4. minus the negative log of 4.1 times 10 to the negative 4th. I get a pH of 10.61. All right, that makes sense. It's a basic solution. pH is above 7. That all lines up. The pOH would be the other value. That gets me to 14. 3.39, it looks like. Any questions on any of that stuff? The other problem gives me this compound. What's his name? No, don't do that. At acidic nomenclature, yes, sir. Acid, yeah, hydronitric acid. I won't keep that. Oh, it's nitride, not nitrogen. But yeah, it's the N, which should be nitride. I says add hydro at the beginning. It get the N. That's hydronitric acid. A little review for you. But since it's an acid, I'm just going to take the negative log of the value it gave me, which in this case is 6.0 E negative 13. Negative log of 6 times 10, whoa, not to the negative 33, to the negative 13. I get 12.22 as my pH. Is this acidic or basic, this solution? It's basic. Look, the pH is above 7. So it's a basic solution, yet we're analyzing an acid. Understand this. If I had a trash can full of base, right? If it was all the way full of a basic solution, and I added 1 drop of H3N to it, 1 drop, is that overall, that solution, is it basic or acidic? It's still basic. It's full of base and 1 drop of acid. But I can still analyze how acidic it is. In this case, whatever this H3N is in, it's mixed with other stuff because it's in a basic solution even though it's acidic. So you have to understand that situationally, when you apply this chemistry, there's a lot of other things that can be going on. What's the pOH of this solution? Yeah, 1.78.